Hi students, this is Rima. So in this video, we'll be starting a new chapter of class 9 CBSE Maths, that is chapter 2. The name of the chapter is Polynomials. Okay, so now let's get started with chapter 2, Polynomials. Okay, so you know what is an algebraic expressions, right? You have learned in the previous class. And what is that? The terms of the form. For example, we have learned one identity, right? X plus y the whole square is what? X plus y the whole square is x square plus 2xy plus y square. Also, you know that x minus y the whole square is x square minus 2xy plus y square. Also, you have studied x plus y into x minus y is what? X square minus y square. So here look at the RHS. X square plus 2xy plus y square is an algebraic expression. X square minus y square is an algebraic expression. So this is an algebraic expression. You know what is an algebraic expression? So here the chapter is polynomials. So what are polynomials? Polynomials is an expression of algebraic terms. Okay, what are algebraic terms? It will be the terms like this. So what is an algebraic term? For example, 5x is an algebraic term. For example, 10y square. This is an algebraic term. So polynomials is an expression of algebraic term which has variables and constants, or sum of several algebraic terms that contain different powers of variable. So what are polynomials? What are polynomials? Is an expression of algebraic terms which has variables and constants, or sum of several algebraic terms. Sum of several algebraic. I'm just defining what is a polynomial, okay, and I'll just explain what it is. Several algebraic terms that contain different power of variables. So a polynomial is an expression of algebraic terms which has variables and constants, or sum of several algebraic terms that contains different powers of variable. So what are variables and constants? For example, we'll take 2x plus 1. We'll take an expression. Okay, the expression is 2x plus 1. So here what is a variable? This x is a variable, right? And what are the constants here? So here this one and 2 are constants. So this is a polynomial. Why? Because it contains algebraic terms which has variables and constants. Here we have variables and constants, or the sum of several algebraic terms. See, you know 2x is an algebraic term, right? So the sum of several algebraic terms that contain different powers of variable. For example, x square plus 2x plus 1. Here we have the power is what? Here the power is x raised to 1. So we have written x, 2x. So 2x plus 1 is also a polynomial, and also x square plus 2x plus 1. In this, the power of the first term is what? 2. The power of the second term, the power of the variable of the second term is 1. So here Polynomial is an expression of algebraic term which has variables and constants. Okay, sum of several algebraic terms that contain different powers of variables. Okay, so we'll take 5x. See here, what is the power of this variable? Power of the variable is 1, right? So what about the constant 5? Is there any variable visible? So you'll think that, okay, so is 5 a polynomial? Yes, 5 is also a polynomial. But you'll think it doesn't have any variable, right? Even though we cannot see any variable here the variable has the power 0. That is why we cannot see. So what is 5? X raised to 0 is what? 5 into 1, which is 5. That is how we get the constant. Here also we have x variable. Here also you can see the variable. But the power of the variable is having 0 as a power. So that is why we get 5 into 1 is equal to 5. Why? Because x raised to 0 is 1. Okay. So polynomials are an expression of algebraic term which has variables and constant. You know what is a constant? Constant is having what? Constant is just numbers 1, 2, 3, 10, 15, like that. Even that is also having variable. But in a constant the variable power is 0. That is why you cannot see a variable in the constant term. Okay. So these kind of constants, we call it as what? Constant polynomials. We'll study that later. Okay. Okay. We'll study this later. But just I mentioned, we came across this constant. That is why I mentioned here constant polynomial. So now we know what is a polynomial, right? So now I'll show you how to generally write a polynomial. Okay. For example, x square plus 5x plus 3. How to write this polynomial? This polynomial is having the variable. Which variable? X variable. So we denote it as p of x is equal to x square plus 5x plus 3. Why? Because this polynomial is having the variable x. That is why we have written like this. For example, now my polynomial is having the variable t cube plus root 2. See, we have t cube plus root 2. So how will denote this? We can denote it as p of t, right? So whatever variable it is, we'll denote inside the bracket. So p of t is this polynomial t cube plus root 2. This is the way of denoting a polynomial. Also, polynomials can have one or more variables also. Okay, but in this chapter we'll be studying polynomials in one variable. For example, what? 2x plus 1 or 2x square plus 3x. This is all polynomials in one variable. Polynomials in one variable. So now there is a general way of writing a polynomial. You know that we can denote a polynomial with the variable x as p of x, right? So the general form of writing a polynomial is how p of x is equal to a n x raised to n plus a n minus 1 x raised to n minus 1 plus a n minus 2 x raised to n minus 2. It continues and plus continues to a 2x square plus a 1x plus a 0, where a0, a1, a2 to an are constants a raised to n not equal to 0. Okay, don't worry seeing this complex form. Okay, so here you don't worry about a n minus 1, a n minus 2, a2, a1 and a0. These all are constants. See, simply for the time being we have denoted it as an minus 1. It can be anything, 3, 4, x, 3, 4, 10. It can be anything. Here we have to concentrate on the variable term. So in the general form, always the variables will be in the what? In the decreasing order. So the highest degree will be writing first. Highest power will be writing first, and then it will come to x. If x raised to n minus 1 is there, we'll write that. Then we'll write x raised to n minus 2, and then it goes on to x square, x, and like that, and the last constant. Okay, so you don't worry about a, n and a. These all are constants. Okay, for example, I'll give you an example. For example, 5 x raised to 7 plus 3x cubed plus 6 x raised to 6 plus 2 x raised to 5 plus x square. So this is a polynomial. Okay, so this general form or the standard form of writing, this is what we'll first write it as p of x. Okay, because it is having the variable x, so we write this polynomial as p of x. Okay, that is fine. And now what did I say? We have to write the polynomial in the decreasing order of the power of the variable. So which is the biggest one here? We have 5x raised to 7. So the highest order degree is 5x raised to 7. So we'll write that 5x raised to 7. And next we have 6x raised to 6, right? So we'll write that 6x raised to 6. Okay, and next we have x raised to 5. We'll write that 2x raised to 5. So we have x raised to 4 here. No, we don't have x raised to 4. So no need to write that. Then after 4, 3. Okay, we have 3. 3x cubed. We'll write that. Then what we have? X square we have. So finished, right? So this is how we generally write the polynomial. Polynomial, whatever variable it is, we'll write p of that variable here. Here it is x, so we have written p of x. And then we will be writing the polynomial in the decreasing order of the power of the variable. So here from 7, 6, 5, 3, 2, like that we will write. Okay, clear? Okay. Now we also have a term that is known as zero polynomial. So imagine here p of x, we have said a n x raised to n. We have defined this term, right? This polynomial. So imagine if all the constants a n minus 1, a n minus 2, a2, a1, a0, all the constants are 0. So then how it will come? If all the constants are 0, then how it will come? It will be p of x will be what? Instead of an, we can write 0, right? 0 x raised to n plus 0 x raised to n minus 1. It goes on plus 0 x square plus 0 x plus 0. So what will be? 0 into any number is 0. And here also 0, 0, 0. So it adds on to 0. If p of x is equal to 0, that is known as a zero polynomial. Okay. And now the degree of the zero polynomial is not defined. So keep in mind, here we don't have any x term, no? So that is what we don't have any degree. So it's not like so the next topic is coefficient. So each term of a polynomial is having a coefficient. Okay, so what is the coefficient? The number in front of each term is called the coefficient. So what is coefficient? Coefficient, the number in front of each term is its coefficient. So how many terms we have? All the terms will be separated either by plus or minus. Okay, so that is also very important. So how we will find the terms, right? It will be separated by plus or minus. So whenever it is separated by plus or minus, that will be a term. So here how many terms it has? Here see, I have 2 plus, so this is a term, this is the term, and this is a term. So 3 terms I am having in my polynomial p of x. So what is the coefficient of x square here? So the coefficient of x square is what? The number in front of each term. So 2 will be my coefficient here. The coefficient of x square is 2. The coefficient of x is what? The number in front of x here. So that is 3. So what is the coefficient of x raised to 0 here? That is 2. You know 2 is what? 2x raised to 0. So the coefficient of x raised to 0 is what? 2. So this is how we find the coefficient of a polynomial. Coefficient of each term of a polynomial. So in a polynomial, this is also very important, okay? In a polynomial, the power of the variable should be a whole number. Whole number means what? 0, 1, 2, like that. It cannot be negative numbers or fractions. It cannot be anything else. It should be a whole number. Okay. For example, here what? 4x raised to 9 plus root 2x raised to 3 plus root 2 by 3. See, this is a polynomial. Why? We have to look only what? Our variables. So here the variable is having the power whole number. Here also the variable is having the power whole number. The constants can be anything. Constants can be anything. It can be negative. It can be irrational numbers. It can be fractions. Leave that. So only here you have to look what is the power of the variable. The power of the variable should definitely be a whole number. If the power of the variable is whole number, then definitely that is a polynomial, or else it is not. So this is a polynomial. Okay, so we'll see 2 more examples. We have learned that for an expression to be a polynomial, the power of the variable should definitely be a whole number, right? So we'll take the example number 1. So here root y minus y, is it a polynomial? We'll see. Okay, what is root y? Root y is what? Is y raised to 1 by 2. We have learned that in the rational number chapter, right? Root y is y raised to 1 by 2. So y raised to 1 by 2 minus y. So what is the power here? Here the power is 1. That is the whole number. So here the power is 1 by 2. That is not a whole number. It's a fraction. So the whole, even though this term is having a whole number as a power, if any of the terms in a polynomial, has the power of the variable not a whole number, then that is not that expression is not a polynomial. We can take the second example. X plus 1 by x is what? X plus, what is 1 by x? 1 by x is, you learned that x raised to minus 1. 1 by x is x raised to minus 1. So here we have a negative power. So definitely this is not a whole number. So the power is not a whole number. So this is also not a polynomial.